Right, in this example we can see two similar triangles. We can see ABC is a large triangle, and because these two lines are parallel, CFE is also a smaller similar triangle. But also, if we take a different perspective, BDC also has a similar triangle inside BFE. Now, there are a couple of sides here, these two here, that are involved in both triangles, and they're going to be important. So let's give them some values. Let's say X and Y. So our first lot of similar triangles we can see here is that, let's take the blue triangle first. We've got BEF, similar to B is common, corresponding to E would be D, and C, the reason is they are equiangular, or angle-angle. So if we pick out our ratios here, we can say that 4 over Y in the smaller triangle would match up with 4 plus X over 3 in the larger triangle. So if we simplify all of that, we can get, well, let's see, 12 equal to 4Y plus XY. And let's see, and also in our red triangle, if we take the smaller ratio, let's say X over Y, to the larger triangle, which is again 4 plus X, over the bigger length here is 3. And we can see that these ratios here are pretty similar. If we cross multiply here, we can get 6x equal to 4y plus xy. So if we compare these two, we can say that 6x is equal to 12. The reason for that is because 6x and 12 are both equal to the same thing, so they must be equal to each other. So then we can say that x is equal to 2. So if this here is 2, then we should be able to find y, because y, well, let's use this triangle here. We can say y over 4 is equal to 3 over 6. So multiplying that by 4, a half by 4, y would be 2. So if the length of EF there must be 2, and FC also 2. Let's do question 10 too while we're here. So if we've got all this information here, let's say that these are all K, then if we group them together, then we'd have 5K. So now let's look at what similar triangles we have here. We're told that all these lines are parallel. So if we take the big triangle, we can see a smaller triangle, similar triangle in here, AGH. So this ratio here, K to 5K, let's write that. So let's first write our similarity statement. AGH is similar to the corresponding angle to G is B, ABC. The reason is that they're equiangular, or angle-angle. So if we say the smaller triangle to the larger triangle is going to be GH over 20, the length of GH. And now this is 1/5, so multiplying that by 20, 1/5 times by 20 is going to be the length of GH. And so we can see that this here must be 4, length of GH. Now if we look at these smaller similar triangles here, because we've got parallel lines, all of these triangles here must be similar. So we've got equal lengths here, which means we can use the idea of a mid-base, which means that because the scale factor would be 2, then these corresponding side lengths would be half. So if this length here was 4, this would be half of that. And again, if we consider the smaller triangle, then this length here would be 1. So DM is this one here, that's equal to 1. And the units are given centimetres.